to do an investigation with you, okay? So I know that you guys have your Chromebooks, you have your lab notebooks or your science notebooks, right? So you're ready to learn. When's the last time you guys did an investigation? I saw one of the other sessions and you guys did some stuff on density.
Yeah.
Think about what you remember about density. Remember that? Alright, you're going to do something. I want you to think about density for a minute. Think about the experiments that you did, the investigations that you did. Now I want you to think about, outside of density, I want you to think about weather. Just for a minute. Think about the weather we're having outside right now. What's happening outside right now? It's raining, right? Does anybody watch the weather on TV and see what's happening back east? What's going on over there?
It's snowing.
Thank you for quiet hand, my friend. It's what? It's snowing like crazy, right? How many of you have ever been in snow? I want you to think about those two things. I want you to think about weather and snow and density. I'm going to have you open up your Chromebooks, and you're going to look at the assignment that's there, and it has some pictures of snow and blizzards. And I want you to attend to the task that's there. Okay, so let's take a look at the objective over here. Read the white, and I want you to read the color markings, okay? So your objective or your learning target today, I will be able to
Explain
the
relationship
between
layering
of
fluids
and
density
by
investigating
various colored salts.
solutions.
All right, a lot of words up here in color. You might see that. And the reason why is because I want to make sure you understand what those words are if you're going to be using them in discussion. So I want you to engage with me about using something called physical response to help you understand the words. So you'll see that I have the word relationship right there, right? And so I like to help myself remember relationship is how things are connected. So can you say relationship? And do the motion like this with me. How things are connected. It's the relationship between the layering, right? So it's the relationship between the layering, can you do that? Of fluids, all right? So I'll do it again. It's the relationship between the, right next to you, do the motions and see if they can tell you the vocabulary. Want to do it with me? See if I can do it.
Wait, no, I do the movement. I do the movement.
Good, right now I'll do it, right? Oh, relationship, good, layering, fluids, good, density, good, and solution. Nice job. All right, let's come back. We know what our objective is as we do the investigation. Let's think about our essential question, or focus question as you guys call it. What is the relationship between the layering of fluids and density? We're going to be thinking about that. And the relationship means how they are connected. I'm going to show you a video. And as you look at this video, I want you to think about what's happening. Why is what you're going to see in just a minute on a YouTube video, why is it happening? Just thinking about the why. What do you notice is happening? Have a conversation with somebody nice. I think it's high pressure, right?
I like when it goes to the top.
Nice. You guys are making some connections from your last investigation, aren't you? But now I want you to think about this question. The stem is I wonder. What do you wonder about? What do you wonder? Maybe it's you wonder what's making it happen. Maybe you wonder why it's blue. What do you wonder? The real world?
How come it like just bounces off a wall and like doesn't like explode into like many pieces?
Good. So why is it bouncing off and not actually joining together? Very good. Yeah?
It's because there's probably oil in it, and oil and water don't mix.
Okay, so you think there might be some oil in it. All right, all of those things are good. What do you think, my friend?
Yeah, like she said, like there's oil and water in it,
Mm-hmm.
but how would there be like bigger and smaller pieces, like different sizes?
Yeah.
Nice wonderings. Nice wonderings. Here's your challenge. I have 4 liquids for you to investigate. Your challenge is to layer all 4 liquids into a section of straw. Each of the liquids is made of water, salt, and food coloring.
It's mixing. It's mixing.
Yeah, it's mixing. That doesn't go.
So it's not getting your layering, huh?
Yeah, so we have,
So you got to rethink about what you can do.
we have to redo it, right?
Mm-hmm.
So it's not even waste the color.
Just seeing if the yellow would go.
Yeah.
Yellow still does. Is somebody recording to make sure that you don't do the same thing again? Right? Make sure you're like, we tried this one, then this one, and this one, and that didn't work. So that way we don't do it again.
So do we take it out?
How do we do this?
Oh, good question. So if
Do
you
we
lift
leave
it
it-
up, it'll just fall into that basin, and that's okay. Figure it out, right?
We put the green first and the yellow flip.
So what can you do to check to see if that's really how it should be?
Be testing it.
Retest it. What would you put on the bottom?
Yellow.
Try that. Yeah. Try
Yellow
it.
first.
Try yellow.
I lift it up? Now we would have yellow on the bottom and
And you'll see if that really is what happened. So you started out with green, and then you put yellow, and it flipped.
flip.
Ooh, that's kind of cool.
So we should put yellow first.
And see if your theory is right.
Yeah, we are. I'm waiting.
There. And then Amaya could do green.
Go ahead, Amaya. Show me. Show me your science skills. And so was your theory right?
Yeah.
So you think it's heavier because it stayed on the bottom. And last time you started with green and it flipped, right? Kind of like what you saw on the bottom. Maybe. Give directions for my friends who have successfully found 2. They're going to go into the 3rd layer to see if they can find what would be 3rd. Just to challenge them. So keep working. Which ones have you experimented with already?
We did blue with all the as like the base, and then we added every color, but it didn't work. And now we're using red.
Okay, so you have a pretty good system. You tried one color and then you tried all the others to see. I like that. Nice powered deductions, but you didn't find that it actually worked, right? It mixed. So what can you tell based on that?
Blue is not the color we should start with.
Good. Blue is not the color you should start with if you tried that. So you know that that's the case. Now you're going to try others, right? What color are you trying now? Oh, can you say that again? What should you do?
Like 2 drops each.
Right, so try
3,
maybe
because remember she
3 or
said
4
bigger?
drops each and not squeezing it. And that'll really give you, I like that. Good scientist. Because maybe if you put more than another color, it will make your results different.
That was 2. I do green.
So you think blue on the bottom.
You just do the green. Now do 3 drops of
3
green.
drops of green.
2, 3.
There.
Now yellow. No, yellow. Yellow.
Oh yeah. That's it. That's it for red.
But the yellow has to go somewhere.
Wait, no, the yellow. The yellow's right there. The green stayed actually.
I do see the yellow.
Yeah, I see the yellow and the green.
Yeah, me too.
It's just very light. Oh, I
Yeah.
see.
Maybe let's see. Let's put a little bit.
I love how you guys are working together collaboratively. Right now I want you to stop your investigation because we need to make sure we have time for cleanup and then some closure. What is the relationship between those layers of the fluids and what you know about density? That's the response that you're going to have. If you look at number 2 on your data sheet, I want you to take a minute to write that, and then we're going to...
Wait, no, density is what makes the solutions layer.
Write it down.
Yeah, I read it down.
Like I'm guessing we would go like